Good morning everyone. So this is our topic today, expressing improper fractions as partial fractions. We'll be revisited by yesterday's biscuit of the deluxe chocolate ginger, to give it its proper title. I just thought you'd like to know that because I got that a bit wrong yesterday. Right, so this is the A-level equivalent of simply doing something like this, saying right, 9 over 2, turn that improper fraction into a mixed number. So what would that do? You would do 9 divided by 2, wouldn't you? Which means it goes in 4 times with 1 left over and a half. And the only thing to remember here is you could write that as 4 plus a half if you wanted to, couldn't you? It means the same thing. Right, so have a look at this example coming up and see if you can work out what you might do first. There's our question. Given that 3x squared minus 3x minus 2 over x minus 1 x minus 2 is identical to a plus b over x minus 1 plus c over x minus 2. Well, the first thing we need to do, we need to know how many times this goes in to that. So in order to do that, we're going to need to do algebraic long division. Now, first up, I'm going to expand x minus 1. So that expands to x squared, take 2 and take another one, take 3x plus 2, doesn't it? And we're going to do 3x squared minus 3x take 2 divided by x squared take 3x plus 2. That's what we want to know. What is that divided by that? And we're going to set this up just like we would do normally, but something's going to freak you out a little bit about this, and that is, well, it might not do. For one thing, they look very, very similar, don't they? But the other thing is that we have got a more complex expression that we're going in. We've normally only done this with two terms, haven't we? And it's normally been just an x. But this time, we always divide by the biggest power, and we don't worry about the other ones. So x squared goes into 3x squared 3 times. Now we multiply everything as we would do before, and that gives us 3x squared. It gives us minus 9x, and it gives us plus 6. And then when we take that away, it gives us no x squareds at all. Negative 3 take negative 9, well, that's adding 9, that's going to give us 6x, and taking 6 is going to give us minus 8, and that 6x minus 8 is the remainder. And the 3, well, that is a, if we look up here. So we've got a. Easy for me to say, I'm going to have to fill up my pen. Right, so here I am, just put that line under there, so that's me a, and then the remainder is all of that. It's the stuff that hasn't been divided by x minus 1, x minus 2 yet. So what we can say is that if we just forget about the a bit for now, we can say that what we are wanting to do is 6x minus 8 over x minus 1, x minus 2 is going to be identical to b over x take 1 plus c over x take 2. And then we're just doing partial fractions as we've done before. So have a little go, see what you get. hopefully you should have that 6x take 8 is identical to b multiplied by x minus 2 plus c multiplied by x minus 1. Now it's up to you. You can go for substitution on this. That's what they do in the book. Personally, I'm a sucker for a simultaneous equation, so that's what I'm going to go for. So do it whichever way you like. See if you get the same answer. If you prefer substitution, I'm going to do it by equating the coefficients. So what I've got here is for x, I've got 6 is going to be equal to b times x would just give me b, c times x would give me c. So b plus c is equal to 6. And then for the normal numbers, for the coefficients, sorry, for the constants, you're going to get negative 8. And negative 2 times b is minus 2b. And negative 1 times c is just minus c. Now what we could do to make this all a little bit easier is to times everything by minus 1, isn't it? So then we're going to have b plus c is equal to 6 for that one, and this one can become 2b plus c equals 8. But however you want to solve that, if I take that from if I take the top one from the bottom one, it'd be nicer. I'll get a positive, and I'll get b as well being 2. And then if I substitute 2 back into here, take 2 away from 6, and c must equal 4. And what all of that means is that we can write at the end, well, we can say that our a equals 3 as well. So if they're asking, as they did, to find the values of a, b and c, then we've done that there. Or it may always often be a good idea, I like to just write out what the whole thing looks like at the end. So you've got the original fraction is going to be equal to 3 plus 2 over x minus 1 plus c was 4 over x minus 2. And that's the only example for today. There's going to be a fair few questions for you to have a nice practice at. And I'd like you just to have a go on exercise 1G on page 18, questions 2, 4, 5, 7, 9 and 10. And like for the last couple of days, I will flash up those questions and answers just after this. Okay, well, enjoy that, my friends, and to see you next week. Oh, and just to add, I will be putting another thing on class charts for your homework for as of tomorrow for the next week, which will be a practice of a bit more of this from the mixed exercise at the end, as per usual. Okay, bye bye.